Hello students, welcome to our student support program for grades 10 and 11, Mathematics. Our topic for today is Indices. This is the first part of the chapter, Indices. So let us start with the objectives of this chapter. At the end of this chapter, you're supposed to understand and use the rules of indices, use and interpret positive, negative, fractional, and zero indices. Now, a little bit about the history of indices. So we have an ancient Greek mathematician, Euclid, who used the term power to represent the number of times a number is multiplied by itself. In the 17th century, the use of raised numbers to denote powers or exponents was introduced. And it was in 1637 that René Descartes used positive indices in the same way as we write them today. Indices are used in many fields, such as computers, electronics, science, engineering, economics, accounting, and finance. So why do we need indices? Indices are also used to express very large numbers or very small numbers in terms of powers of 10. For example, if I have to write the distance from the Earth to the Moon, I can write it as 4 times 10 to the power of 5 kilometers. So in today's lesson, we will learn the following. Firstly, how to write a number in index form and in expanded form. Secondly, the multiplication law of indices. And finally, the division law of indices. So let us start. Suppose I have this 6 to the power of 4. We read it as 6 raised to the power or index of 4. The 6 is called the base and the 4 is called the power. We can also use the terms index or exponent. So 6 to the power of 4 will mean 6 times 6 times 6 times 6. In other words, we multiply by 6 4 times. So this is 6 to the power of 4 and we call it the index form. The 6 times 6 times 6 times 6 is called the expanded form. Let us take a first example. Write the following in expanded form. 5 to the power of 3 and 3 to the power of 6. So 5 to the power of 3 will mean 5 times 5 times 5. 3 to the power of 6 will be 3 times 3 times 3 times 3 times 3 times 3. In other words, we multiply by 3 6 times. A second example. Now we are going to learn how to write in index form. Part A. So we have 6 times 6 times 6 times 6 times 6. So here 6 is being multiplied by itself 5 times. Part B. M times M times M times N times N. And part C. A times A times B times B times B times C. So for part A, the answer will simply be 6 to the power of 5. As I mentioned, we have multiplied by 6 5 times. Now for part B. M is being multiplied by itself 3 times. So we will have M to the power of 3. And N is being multiplied by itself twice. So we will have N to the power of 2. So the answer will be M cubed N square. Now for part C, can you try it on your own? So here A will be raised to the power of 2, B to the power of 3, and C is being raised to the power of 1. But we usually do not write the 1. We simply put C. Now let us consider the following. So in the first column, I will have A, second column B, the next column will be A times B, the fourth column we will write it in expanded form, and in the last column we will write in index form. So A is 2 to the power of 1 and B is 2 to the power of 2. So what will be A times B? 2 to the power of 1 times 2 to the power of 2. Now, if I have to write it in expanded form, I will have 2 for 2 to the power of 1, and for 2 to the power of 2, it will be 2 times 2. So this is the expanded form. Now, if I have to write it in index form, it will be 2 raised to the power of 3. Let us consider the second example. 2 to the power of 1 for A, and for B, 2 to the power of 3. So A times B will be 2 to the power of 1 times 2 to the power of 3. Writing this in expanded form, we will have 2 for 2 to the power of 1, and for 2 to the power of 3, we will have to write 2 times 2 times 2. So in index form, it will be 2 raised to the power of 4. Next one. A is 2 to the power of 2, B is 2 to the power of 2 again, so A times B will be 2 to the power of 2 times 2 to the power of 2. Writing in expanded form, I will have 2 times 2 times 2 times 2, and in index form, it will be 2 raised to the power of 4. The last one now. A is 2 to the power of 2, B is 2 to the power of 3, A times B will be 2 to the power of 2 times 2 to the power of 3. In expanded form now, I will have to multiply 2 by itself 5 times. So in index form, it will be 2 raised to the power of 5. Now I will give you a few seconds. Just observe what we have done. So what do you notice? 2 to the power of 1 times 2 to the power of 2 is 2 to the power of 3. In other words, it is equal to 2 to the power of 1 plus 2. 2 to the power of 1 times 2 to the power of 3 is equal to 2 to the power of 4, that is 2 to the power of 1 plus 3. 2 to the power of 2 times 2 to the power of 2 is 2 to the power of 4, that is 2 to the power of 2 plus 2. 2 to the power of 2 times 2 to the power of 3 was 2 to the power of 5, that is 2 to the power of 2 plus 3. So what can you observe? You can see that we are adding the powers to get the answer. In other words, a to the power of x times a to the power of y will give me a to the power of x plus y. And this is what we call the multiplication law of indices. But you have to be careful. We can only apply the law of indices, the multiplication law of indices, if we have the same base. So a to the power of x times a to the power of y will give me a to the power of x plus y. Now let us take a few examples. First one, 5 to the power of 2 times 5 to the power of 5. So we can see that we have the same base. What we have to do is just add the powers. So 5 to the power of 2 plus 5, which is 5 to the power of 7. Part B, 3 to the power of 3 times 3 to the power of 7 will give me 3 to the power of 10, that is 3 plus 7. Part C, 2 to the power of 4 times 2 to the power of 6 which will give me 2 to the power of 4 plus 6, that is 2 to the power of 10. Remember, you have to check that we have the same base before we can apply the multiplication law. Part D now, 2p power 5 times 3p squared. So what I have done is break it into parts. 2 times p power 5 times 3 times p power 2. So 2 times 3 will give me 6, and p power 5 times p power 2 will be p power 7. Next one, 3x squared times 4x power 6 will give me 3 times 4, which is 12. X squared times x power 6, which will give me x to the power of 8. So now you have a few questions to practice on the multiplication law of indices. Now we move on to the next part. Let us consider the following. So here we will have a divided by b instead of a multiplied by b. Let us consider the following: 2 to the power of 3 for a and b 2 to the power of 2. Now a divided by b will give me 2 to the power of 3 divided by 2 to the power of 2. If we write it in expanded form, we will have 2 times 2 times 2 over 2 times 2. Now 2 will cancel with 2. Again 2 will cancel, and I will get 2 to the power of 1 in the last column because only one 2 is left in the numerator. Next one, 2 to the power of 4 for the value of a, and b 2 to the power of 2. So a divided by b will be 2 to the power of 4 divided by 2 to the power of 2. So writing in expanded form and simplifying, we can see that we have 2 times 2 in the numerator. In the last column, writing in index form, I will get 2 to the power of 2. Next one, 2 to the power of 4 as value for a, 2 to the power of 3 for b. So writing a divided by b, I will have 2 to the power of 4 divided by 2 to the power of 3. Now, writing this in expanded form, I will get 2 times 2 times 2 times 2 over 2 times 2 times 2. Simplifying, I am left with 2 in the numerator. So in index form, I will get 2 to the power of 1. Finally, a 2 to the power of 5, b 2 to the power of 3. So I will get 2 to the power of 5 divided by 2 to the power of 3. Writing in expanded form, I will have 2 multiplied by itself 5 times in the numerator and 2 multiplied by itself 3 times in the denominator. Simplifying, I will get 2 times 2 in the numerator. Writing it in index form, I get 2 to the power of 2. So again, what do you notice from this table? So 2 to the power of 3 divided by 2 to the power of 2 gave me 2 to the power of 1, that is 2 to the power of 3 minus 2. 2 to the power of 4 divided by 2 to the power of 2 gave me as answer 2 to the power of 2, that is 2 to the power of 4 minus 2. 2 to the power of 4 divided by 2 to the power of 3 gave us answer 2 to the power of 1, that is 2 to the power of 4 minus 3. Finally, 2 to the power of 5 divided by 2 to the power of 3 gave us answer 2 to the power of 2, that is 2 to the power of 5 minus 3. So what can you see? When we are dividing the indices with the same base, what we are doing, we are subtracting the powers. So if I have a to the power of x divided by a to the power of y, this will give me a to the power of x minus y. And this is called the division law of indices. Just as for the multiplication law, in the division law as well, we need to check that we have the same base before applying the division law. Let us take one example. Simplify the following. So 4 power 5 divided by 4 power 2 will give me 4 to the power of 5 minus 2. That is 4 to the power of 3. 3 to the power of 7 divided by 3 power 4 will give me 3 raised to the power of 3. That is 7 minus 4. 9 to the power of 8 divided by 9 to the power of 3 will give me 9 to the power of 5. That is 8 minus 3. Now a power 6 divided by a power 3 will give me a power 3. 6 minus 3, which is 3. This one, 6m power 7 divided by 2m square. So I have written it as a fraction, 6m power 7 over 2m square. And we can see that I can divide by 2. 6 divided by 2 will give me 3. Now m power 7 divided by m power 2 will give me m to the power of 5. So the answer will be 3m power 5. The last one, 36s power 10 divided by 9s power 5. So writing it as a fraction, I divide by 9, I get 1 in the denominator, and in the numerator I will get 4. Now s power 10 divided by s power 5 will give me s to the power of 10 minus 5, that is s power 5. So the final answer will be 4s power 5. F power 4 times f power 7 over f power 5. So here you can see that we have multiplication and division. We will have to apply both the multiplication law and the division law. So in the numerator, because I have multiplication, I need to add the powers. So I will get f to the power of 4 plus 7 over f power 5, which will give me f to the power of 11 minus 5. Because we are dividing, we subtract the powers. So we get f to the power of 6. Next one, 5n power 6 times 4n power 8 over 2n power 5. So again, we have to multiply and divide. 5 times 4 gives me 20. N to the power of 6 plus 8, which is n to the power of 14, over 2n power 5. So I divide by 2 and I get 10. N to the power of 14 minus 5, which will give me 10n power 9. Now you have a few questions to practice on division law. So in today's lesson, we have learned about the index form and the expanded form. So this is an example, 6 power 4, which is 6 times 6 times 6 times 6. And we have learned about the multiplication law, which is a power x times a power y, which gives me a to the power of x plus y. But remember, we need to have the same base. And finally, we learned about a power x divided by a power y, which is a to the power of x minus y. So students, this is the end of the first lesson on indices. Until we meet again, it's goodbye.